Welcome to Pure Mathematics 1, Chapter 6, Integration, Topic, Finding Volumes by Integration. Let's say you have a curve in here, and you have a piece of area which is limited by 2 points A and B, 2 lines here. And you this part, and you rotate it around the axis 360 degrees, which is 1 round. From here you obtain this one. You will obtain a solid. And this solid is called solid of revolution. And now we can use integration to determine the volume of the solid. And now we will determine the volume of revolution. The general rule for that, we will have the volume equal to pi multiplied with the integral b and a. A is the lower limit, b the upper limit, and in this case it is rotating along the x-axis, so we will have y squared with respect to x. So let's say I will have an example here to illustrate this formula. I have y equal to x squared plus 1, and I want to rotate 360 degrees about the x-axis between the line x equal to 2 and x equal to 4. So find the volume of revolution. Find V. Okay, now we'll solve this one. So first of all, volume I will substitute into here, equal to pi multiplied by, here's 4 and here's 2, my y squared. At first I have my y equal to this one, so my y squared would be x squared plus 1 squared dx, which will be equal to pi. Remember to add pi in here, but it will determine that this one we are talking about volume. 4 and 2, and we have x to the power 4 plus 2x squared plus 1 dx. And now we will have this one. We integrate the one inside here like what we used to do. X to the power 5 over 5 plus 2x cubed over 3 plus x. And here's 4, and here's 2, and we need to add pi in here. Don't forget to add pi, equal to. Now we take 3 with pi out here, multiply by 3,772 over 15, which is when we substitute 4 into here, minus when we substitute 2 into here, 206 over 15 equal to 3,566 pi over 15. So the volume of this one equal to 3,566 pi over 15. From the previous one, we can find the volume of a solid of revolution when it rotates about the x-axis. So now we can also find the volume of revolution of a curve which rotates about the y-axis. So we have the general formula is that volume of revolution equal to pi multiplied by b and a, the integral. Then we have x squared now with respect to y dy. So let's say I have the curve y equal to x plus 2 and I rotate 360 degrees about y-axis, right? Y-axis, and in between y equal to 1 and y equal to 5. Okay, now I would find the volume of this one. So here's the way I will solve it. Because this one is x squared, so I must write x squared in terms of y. So from here I have y equal to x plus 2. So x equal to y minus 2. So x squared equal to y minus 2 squared, which is equal to y squared minus 4y plus 4. So now I would write this one into volume of revolution equal to pi. My integral will be 5. Here's 1. Because my x squared equal to this one, so I would write down y squared minus 4y plus 4 dy. Please remember that when we rotate about the y-axis, this one is dy, and here's x squared, and vice versa for the other one. Equal to, here you need to add pi's in here, y cubed over 3 minus 4y squared over 2 plus 4y. Here's 5 and 1. So we have this one equal to 35 over 3 pi out here minus 7 over 3. When we substitute 5 into here, we get 35 over 3, and when we substitute 1, we get 7 over 3. So the volume of this one equal to 28 pi over 3.